Okay, welcome back to our math video series. Today we are chatting about series and sequences as they relate to arithmetic ones. Specifically, we'll be looking at terms, differences, number of terms, playing with formulas for arithmetic sequences. We'll also then look at finding sums of arithmetic sequences. We typically call those series. And finally, we'll solve an applied problem. To begin with, what is an arithmetic sequence, or what kind of concept are we looking at? So to start, I want you to look for a pattern in these two different questions. The first one, you have to try and find which of these, A, B, C, or D, is the same as this one. You might have to rotate or do something with it. And finally, in this one, you need to find what pattern of colors should be here in the bottom. Is it A, B, C, D, E, or F? Which pattern should be down here? Pause the tape so we don't spoil it, and you can see which ones are the right ones when you press play. So see if you can figure those out. Okay, hopefully you've paused and you've figured out your answer. I'm going with this first one as letter C. If you rotate that just 90 degrees clockwise, I believe you'll get a shape that looks similar to this one. Now this one down in the bottom, I'm trying to find a pattern with that. So here I see, I don't know, 3, 2, maybe blue should be in this quadrant here. I'm thinking. I don't know. This one had a red. Maybe this one here should be red. Let me get my red pen. Do I have any like that yet? Yeah, red, blue. Yeah, red, blue. I'm thinking maybe it should be, I don't know about the green though. Anyway, my point is, you've probably figured out the pattern. Just quickly on the video here, I didn't figure out what the answer was beforehand, but I think you sort of see what I'm trying to do here is to try and find a pattern between these things. And that's our topic for today, is looking at an arithmetic pattern. So these were geometric or color kind of patterns. What we want to look at today is a different kind of pattern, one specifically called an arithmetic pattern. We call it an arithmetic sequence when we have a set of numbers, or a sequence, a list of numbers in which there's a common difference. For example, if I had these ones, say 2, 3, 5, 9, 16, if I looked at that list of numbers, is there a pattern? Here I see a difference of 1, a difference of 2, a difference of 4, a difference of 7. I'm not seeing a pattern there. But how about this pattern? How about if I had 3, 5, 7, 9, 11, etc.? You probably quickly see that there is a pattern there, and that I am increasing each of the previous numbers by 2. So this here is an example of an arithmetic sequence. A sequence in which there's a list of numbers and there is always a common difference of 2. Now, any arithmetic sequence can be defined by knowing two things about that sequence. First thing we want to know is what the first term of the sequence is. And the other piece of information we want to know is the common difference. So in these two examples here, I can easily say, well, my first term is 3, and my common difference, it looks like I'm going up by 2. So there I've helped define what this arithmetic sequence is. With this one, first term would be 2, and the difference, 7, yeah, the difference is I'm going up by 7. So there, if I wanted to, then I could point out whatever number in the future is. If I wanted to know what the, say, the 20th term was, knowing the first and the difference, I should be able to do that. And I do that using this arithmetic sequence formula. And it's fairly straightforward. It just indicates that any term in the sequence is equal to, I guess I could move these things down, the nth term or any term in the sequence is equal to the first term, that's what A1 stands for, plus n, that's the number of terms, n minus 1 times whatever the difference is. Let me draw sort of arrows. That's that, n is that, and d is that, times by the difference. So it's like any other formula. I have 1, 2, 3, 4 variables, and as long as I know 3 of them, I should be able to solve for the fourth one. Let's try that for a couple of questions. Here the question says, find the 12th term of the arithmetic sequence. Okay? First thing I would do is identify what I know. I know the first term is 2, and I know that the common difference is 3. So if they want to know the 12th term, here's my formula. an is equal to a1 plus n minus 1 times d. Notice that even if my formula is there, I just am in the habit of writing it down. So they want the 12th term. So a12 is equal to, first term, 2, plus the number of terms, well, they're wanting the 12th one, so there will be 12 terms, minus 1, multiplied by the difference, which is 3. So determining the 12th term then is 2 plus 12 minus 1 is 11. 11 times 3 is 33. I'll write it like this. And 33 plus 2 is 35. So if I had continued this out for 12 terms, maybe I'll just do that. 14, 17, 20, 23, 26, 29, 32, 35. This one would be my 12th term. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. Sure. So that formula then helps me identify any term in the sequence. Here's another one. Find the 10th term of the arithmetic sequence. 10, 4, minus 2, etc. Here this one's a little bit different because notice they're going down. This time, sure, my first term is 10, but what would my difference be? It can't be the same as one we just did. This one I was going up by 3, so my difference was 3. So what would the difference here be? Sure, minus 6. So I would use this same formula, plug numbers in, and be able to solve for the 10th term. Let's move on. You can do that. Let's move on and try another question. Here's a question where they tell me in an arithmetic sequence the 9th term is 14 and the 18th term is 41. Oh, so they don't tell me what the first term or what the difference is, but they want me to write the first 5 terms of the sequence. Well, maybe I'm in a little bit of trouble with this one, because here's my formula. A9 is 14, so I would know that the 9th term is 14 is equal to, I don't know the first term. The number of terms, yeah, I know that would be 9, but I also don't know what the difference is. So in my equation here, I have 2 unknowns. However, I have another point or another number that's in the sequence for which I could plug things in, and I'd also get 2 unknowns. So if I'm talking about the same sequence and I have 2 unknowns, I can solve system of equations. Let's see how you do that with these. So here's my formula. an is equal to first term plus n minus 1 times the difference. So if I'm using a9, let's write that, for the 9th term, I'm going to plug stuff in. So the 9th term is 14. So the 9th term is 14 is equal to, first term, I don't know, plus n is the number of terms, that's 9 in this case, minus 1 times d. So this works out to 14 is equal to a1 plus 8d. Okay, so that's for the 9th term. There's an equation that is describing the sequence using the information for the 9th term. Let's try the same thing with the 18th term. The 18th term is 41, so plugging the numbers in again, I'd have 41 is equal to the first term plus 18 minus 1 times the difference. Oh, I don't know the difference. So simplifying a bit gives me 41 is equal to the first term plus 17d. Here I have two equations, both describing the same sequence, where I have two identical unknowns. If I have that, I can solve system of equations. And these ones to solve are quite simple. 41 is equal to the first term plus 17d, and 14 is equal to the first term plus 8d. So when I look at these, I could solve by substitution, but this one is lined up just perfectly for solving by elimination. So I'm going to subtract each variable. So 41 take away 14, I'm calling that, is that 27? About? A1 minus A1 is nothing. 17 minus 8 would be 9d. So when I divide here, that gives me my difference is equal to 3. So now I know what the difference is. That was one of the questions they asked in the question. What's the difference? Now I can solve for my first term. To do that, I can take this difference and plug it into either of those equations up there. Let's solve for d using this one. This numbers are a little bit smaller, a little bit easier to do. So 14 is equal to the first term plus 8 times whatever the difference is. The difference is 3. 8 3s are 24. And doing my simplifying to solve for the first term, I bring this over and subtract. I get negative 10. So my first term is negative 10. My difference is 3. So now if they want to write the first 5 terms, I start with minus 10. My next one will be minus 7, minus 4, minus 1, positive 2, 5, etc. Okay, so that's a nice question. So if they give me what two of the terms are, I can substitute those into our equation for an arithmetic sequence, and I come up with two equations, each having the same variables that describe the sequence. Then solve system of equations like we've done in the past. Now, in addition to just describing a sequence and being able to find that pattern, also it's valuable to be able to add up a sequence sometime. So here are 2, 4, 6, 8. There's an arithmetic sequence. First term's 2. Difference is also 2. If I were to add up each of the numbers in that list or in the numbers in that sequence, I would call that a series. So if I add up the numbers in a sequence, I call that a series. Here's a formula that we can use because it would be handy. If I could add things up, it'd be handy to use a formula. And the formula says this: the sum of a certain number of terms in a series is equal to the number of terms divided by 2 multiplied by the first plus the last term, or whichever term that you're trying to find the sum of all of those. Let's try an example of that. A stack of poles has 1 pole on top, 2 poles on the second layer, 3 poles on the next, and so on for 20 layers. And my question is, how many poles are there in the stack? Well, certainly I could go, well, 1 plus 2 plus 3 plus 4 plus, and I could keep going 20 times. However, what I could do is I could use my formula here. My formula says the sum of a certain number of terms in a series is equal to the number of terms divided by 2 multiplied by the first term plus the last term. So in this case here, I have 20 layers. Since there's 1 on the first layer, 2 on the second, I assume there's going to be 20 on the last layer. So the sum of those 20 numbers in that series are equal to 20 over 2 times first term was 1 plus the last term was 20. So 20 over 2 would be 10. 1 plus 20 is 21. 10 times 21. There'd be 210 poles in that stack of poles. So there's an example of using the arithmetic sum formula to determine how many poles would be in a stack. So in this section we have then talked about arithmetic patterns. And certainly there are, countless patterns in the world, but often arithmetic are ones that we see and they'll be useful. And arithmetic, we've seen that are patterns that have a common difference. And we found that there was two formulas that we could use to solve questions that deal with arithmetic patterns. This would be a term formula, and this would be a sum formula for determining the the number of poles, or the number of adding up the numbers in a list. Okay, thanks. We'll talk to you later.